just to talk about the energy model itself, we use the energy model over and over again. During the early strategizing of what we should do, how much we should spend on the glass, how high performance the glass should be versus the chiller. So the first thing we had to do, kind of like Chrissy at Lincoln Center, figure out how it was working now. So we ended up deploying data loggers throughout the UN, getting all the energy bills, creating it is still the most complicated energy model Syska's ever built, and then calibrating it using the data that we got from the loggers of how they ran the fans, how they did or did not turn off the lights, and sometimes they never turn off the lights, and then how the fans were running, how the actual operation staff that was also there for the last 50 years just generally worked the building. And then we used that calibrated model to run kind of games on what kind of chiller plant should we have, what kind of glass we should have, what kind of effect would active blinds have on the performance of the building, what would a 2-pipe versus 4-pipe versus VAV system look like for the Secretariat. So we used it over and over again. We ended up with basically our sexy chiller plant is located right at the bottom of this. 42nd Street is here, 48th is here. FDR runs underneath the United Nations, and this is First Avenue. So we have Con Ed steam, Con Ed electricity enters the facility. It used to be an all-steam chiller plant, and we ended up going with a hybrid plant now for redundancy in fuel source. So if we ever were to lose Con Ed steam, we could run on electricity. If we were to lose electricity, we could use our generators to run those turbines, the electric turbines. Some of the electric machines are run. So the mission critical functions like the Secretariat, the Security Council, or the situation centers, the UN actually has peacekeeping forces and they need to communicate with them. There are 24/7 mission critical operation centers within the campus that need to keep running no matter what happens to the utility service. Also, there's a contiguous basement that runs from 42nd to 47th Street beneath this whole campus, and there's 5 levels of basements. If you can imagine the water level when Sandy hit, we're right on the water, it was about 3 feet above the 3rd basement level. So the 5th basement level where the river water intakes were, the 4th basement level where the chillers sit was basically completely filled with water. And as you look down, you basically saw a swimming pool after Sandy hit. Does anybody have any?
Do you want your presentation now?
Yeah, we can go back to mine. Good job. Thanks. The Secretariat Building has their mechanical floors set up basically every 10 stories. So it would be on the 6th, 16th, and 28th floor. And we worked with Bob Pinchas's group and John Breesky to look at different iterations of what kind of curtain wall and how high performance it should be. One of the things that became apparent to us was that we had to incorporate all the new energy codes kind of and keep the look of the UN. So we didn't have outside air economizer, we didn't have waterside economizer when we arrived, but we had to incorporate them into the existing louvers. We weren't going to be able to punch new holes in the facade of the UN. It just was not happening. These were the 4 major product goals: showcase of sustainability, as Michael had said, bring the facility to code compliance, increase security. There's a blast component to all the design work, the architectural work. There's standoff distances at the perimeter and hardening of all the utilities that enter the site that are kind of transparent when you look at it. And then it was really a historic preservation project too on the interiors. A lot of the wood and the materials and the interior finishes were donated by member states, member countries. They had to be taken off, refurbished, reinstalled. So where did the savings come from? This is a neat chart. We saved approximately 70% on site energy in BTUs and 55%, as Michael said, in dollar savings. The next slide is a little bit of a pie that may or may not be confusing to you because these numbers they both add before and after. They add up to 100%. And one of the things that should jump out at you is that we used to have steam chillers consuming 31% of the energy on the campus. We stopped using them, and we went to high-efficiency electric chillers. So although some of these numbers seem to go up, the pie is smaller, though. We're looking at this portion of the energy pie. So it's a little bit of a confusing slide, but it kind of tells the story of where the energy was used pre-renovation and where it's being used now post-renovation. So we're still, as Michael said, we handed and tossed the keys to the facilities staff about a month ago. And we're still on site, kind of going through, kicking the tires, making sure all the BMS sequences work, making sure that all the, the demand ventilation, the active blinds, everything kind of is in sync. And really, until you really work the building and go through something like the General Assembly, you really need to see it in operation when it's in full swing to know what's working, what's not, and what has to get tweaked. So we're having that kind of fun now. This is a picture of the General Assembly during its renovation. One of the things that was a challenge, a lot of agencies were involved in the standoff distance and what kind of blast requirements had to be built into the campus. And having the FDR run underneath it was an opportunity for something to happen on the FDR that might affect the UN. We used that opportunity to flip around the occupied space from away the FDR and put all the mechanical systems for the conference building on top of the FDR, kind of using the mechanical systems as a buffer zone above the FDR. That also gave us the ability to install displacement ventilation in these large conference rooms, where we would normally have had, if they stayed the way they were, we wouldn't have had that room to run the ductwork or get the air plenum underneath the conference rooms. So when we were first approached with what to do with this, the engineers at EYP were able to dive in and figure out ways to engineer and displacement ventilation into the newly renovated rooms. This is post-renovation. It's kind of more of a fisheye view of it. This is the buffer zone underneath the conference building, one of the mechanical rooms. The campus used to have 5 208-volt vaults spread throughout the UN. One of them was on the 28th floor, and the joke was the only thing Iraq and Iran could agree on is that no one wanted to sit on 29 because all the screens had like waves through them. Everyone was worried about EMF. We ended up getting rid of the 208 system, installing 2 large 40-volt vaults. This is actually at the base of the Secretariat Building. This is some of the new gear. There's a 10-megawatt emergency generator plant on the north end of the campus. Another big consumer of energy is that over time, the UN's a really flat organization. Once you're inside, department heads were like fiefdoms, and each one of them had their own server for their own software that helped them run the department. And the safest place for that software and that server was under the guy's desk. So we had to hunt for all the servers, build a tier 3 mission critical data center for the UN, and then there was probably a lot of diplomacy used to get those servers out of the desks and underneath into the data center we built. But once we built that data center, it was a really high performance, high efficiency data center. It took those heat loads from underneath the desk that were running 24/7, and we were able to really manage that energy. Here's a little picture of our chiller plant. As mentioned before, we have a river water intake. We use that river water as the heat rejection and a free energy source for waterside economizer. About 90% of the air handling systems were able to incorporate airside economizer, but there were some systems where the original MERs were so tight we couldn't get the louvers into the historic structure to make airside work. And then those systems have waterside. All the mission critical pieces and components that cool traditional data center, IDF, the broadcast MER, broadcast equipment rooms, all are capable of waterside economizer. And that's about it. Thanks.